All right, let's dive right in. Today, we are going to unpack one of the most incredible stories in all of modern technology. We're talking about how we create the microchips that power, well, literally everything in our digital lives. So, here's a wild question for you. How do you turn something as ordinary as sand into magic? It sounds like something out of a fairy tale, right? But the device you're watching this on, your phone, your car, it all starts with this seemingly impossible transformation. Well, the secret ingredient is silicon. Sand, or more specifically quartz, gets refined into this ultra-pure silicon, and that becomes the canvas, the very foundation for all the technological marvels we're about to get into. And this is where the real magic starts to happen. We're about to see how this basic element gets transformed into something with genuine superpowers, all thanks to one single idea that completely changed the world. That big idea is VLSI. That stands for Very Large-Scale Integration. Really, just think of it as the ultimate art of miniaturization. It's the core technology that lets us shrink down millions and now billions of tiny electronic switches called transistors and just cram them onto a single microchip. I mean, that just paints an incredible picture, right? Every single one of those transistors acts like a microscopic light switch, processing information just by turning on and off. And being able to fit billions of them on a chip the size of your fingernail is exactly what gives our devices all their incredible power and speed. Okay, so we know we can fit billions of these switches on a tiny chip. But how do you actually design one of these digital brains? It's kind of like being a city planner, but on a microscopic scale. Let's take a look at the blueprint.
So chip design is actually split into two halves, and this is absolutely crucial for managing the insane complexity. First up, you've got the front-end design. Think of this as designing the chip's brain. This is where engineers define all the logic and figure out what the chip is going to do. Then you've got the back end. This is like creating a super detailed city map. This part is all about the physical layout, figuring out exactly how to place and connect those billions of transistors in the most efficient way possible. So one team designs the mind, the other builds the city it lives in.
And this whole journey from an idea to a final blueprint follows a pretty clear path. It all starts with RTL design, where engineers write code, a lot like software developers, to describe what the chip needs to do. Next, and this is huge, is design verification. This is all about testing, running millions of simulations to make sure the code is absolutely perfect. Then, in synthesis, that code gets automatically turned into a schematic of basic electronic parts. After that, it's physical design. This is where they lay out that city map, placing every single transistor and routing every tiny wire. And the final step? Tape out. That's the point of no return. The digital blueprint is locked in and sent off to the factory to be made into a real, physical chip. Now, within that whole complex process, there are a ton of specialized roles. But one of the most critical is the DFT engineer, which stands for Design for Test. And silicon design engineer Nikita Chavala puts it perfectly. A DFT engineer's entire job is to build testing logic right into the chip's design. And this is so important because, when a chip is controlling something like a self-driving car, you need to be 100% certain it can check itself for errors in real time. So they're basically making the chip smart enough to diagnose its own problems.
So we've seen the technology, but who are the people behind it all? Let's switch gears and focus on the engineers. What does it actually take to build a career in this incredible field?
This slide gives us a fantastic real-world roadmap, using Nikita Chavala's career as an example. It usually starts with a bachelor's in engineering, but then it gets more specialized, with graduate studies in VLSI design. A really key step is getting that hands-on experience through internships at major companies, which, if all goes well, leads to landing a full-time job in this super competitive industry.
So what does it really take to succeed? Well, of course, you need a rock-solid foundation in the basics, like digital electronics, and you've got to know a hardware coding language like Verilog. But what really seems to set people apart is a certain mindset. It's this ability to think behind the problem, to not just spot an error, but to truly understand its root cause. That's a skill you just can't learn from a textbook, and it's why getting hands-on experience with real projects is so valuable.
Okay, let's zoom out from the individual engineer and look at the world stage, because these tiny little chips have become absolutely central to global economics and, yes, even politics. I'm sure we all remember this. The pandemic hit, and suddenly, everyone on the planet needed a new laptop, better Wi-Fi, more gadgets to work from home. This caused this massive, totally unexpected spike in demand that the global supply chain just wasn't ready for, and that led to the infamous chip shortage. That shortage was a huge wake-up call. Countries all over the world suddenly realized they were dangerously dependent on just a few places for their chips. And that sparked this global race for what they call supply chain resilience, with nations like the US, Europe, and India now investing billions and billions of dollars to bring chip production back home. And to get a sense of the sheer scale of these investments, just look at this number. This represents the funding for just one new semiconductor plant in India. That's an amount that translates to over $3 billion US. And that investment is expected to create a massive ripple effect. This one plant in Assam is aiming to produce 48 million chips per day, and it's expected to create around 30,000 jobs. It is a huge statement of intent, and it shows just how seriously countries are taking this race to become semiconductor superpowers.
So after hearing all that, what if you're feeling inspired? Maybe you're thinking, wow, this is a dynamic industry. How do I get in on this? Well, let's look at some of the concrete steps you can take.
There are actually several different pathways. A master's degree is a really common route, but you can also look into specialized coaching institutes to learn specific high-demand skills. There are also industry-focused research programs out there that offer some really rigorous training. And, of course, like any field, building your network through LinkedIn and showing up to industry events is absolutely key.
And if you want to keep learning, there is a ton of great information out there for you. On YouTube, channels like NISO Academy and VLSI for All have excellent tutorials. And for some deeper dives, podcasts like SemiWiki.com and The Circuit give you some fantastic insights from inside the industry.
Which brings us right to our final thought. The next wave of technology, we're talking true AI, fully autonomous cars, advanced robotics. It's all going to require chips that are way more powerful and complex than anything we have today. The question isn't just what these chips will do, but who. Who are going to be the architects of this future? It might just be